I love it when a plan comes together. First, I want to thank you, Vol, and Zaid, and John Grimala, who's not with us today, for making this possible. Flextronics, of course, for making their space available to us and innovating on the original Open19 designs that LinkedIn had come up with. It's great to be here. We're going to talk about specifically the edge. I love the fact that we talked about Predix, we talked a little bit about HPE. Zay just showed you a little bit about the edge use cases for LinkedIn, and that's all we're going to talk about is edge, because that's effectively where Vapor IO exists and what we aim to accomplish. But just to parrot Kara earlier, how many of you, just by raising your hands, how many of you heard the phrase economies of scale? Everybody, right? What about economies of innovation? Not as many people. Kara had said this collective genius, and others have said we're in this knowledge economy. And it's absolutely correct. But by being here today, you are part of that engine that is driving that transformative change. You guys are part of the economies of innovation that is happening right now with Open19. So I guess you should really give yourselves a round of applause, please, just really quickly, for being part of that change. It's a big deal. It's a very big deal. So we're talking about the speed of light. I don't know if anybody knows who John Carmack is, but he was the creator of Doom and Wolfenstein and Quake and a bunch of other video games for ID. And he was literally writing this as these video games were sort of the first video games to be latency driven. In these games, the idea is to have a low latency connection so you can frag. If you're gamers, you'll understand that. John was famously quoted as saying the speed of light sucks, and it absolutely does. And that's because we are moving from business-critical applications to life-critical applications. Think about that. Today on the planet, there's somewhere around 15, 16 zettabytes of data. By 2020, there's going to be at least 40 to 50 zettabytes of data. And IDC just recently predicted that by 2025, there would be 163 zettabytes of data on this planet, and we will be creating over 163 zettabytes of data every single year. So while we are moving from core to edge, we need to be thinking about data centers as in-tier architecture. And where does that ingest start? Where does the decentralized machine learning start? Where does the low latency artificial intelligence start? These are the things that Vapor is trying to solve from an infrastructure standpoint. So I'm not picking on anybody here. I'm just talking about geography. The cloud and the internet as we know it was built out exactly the same way as airlines and the way they traveled their routes from the beginning of the airline industry to pretty much today. I travel to Pittsburgh quite a bit, and I can't get there directly. And in the airline industry, this is called hub and spoke. And the internet was built exactly like the airline industry. You've got May East, you've got May West, you've got carrier hotels, you've got interconnects, and you traverse this information superhighway with fiber optics in the ground. And you've got tier 1 data center markets, you've got tier 2 data center markets. But when you're moving from business critical to life critical infrastructure, where a medical sensor needs to make a low latency decision about how to save a life, or an autonomous vehicle is driving around and it needs to detect not via the car, but via the infrastructure, via the I2V, the infrastructure to vehicle technology. It needs to make a decision around a 170-degree turn where there's a dog and a human running across the street. How does an autonomous vehicle make a decision about how to do that low latency artificial intelligence decision? So the world today has been architected with hub and spoke. And as an example, there is exactly 4 data centers, 4 physical big million square feet plus data centers for AWS today. And of course, lots of static content can be delivered to you through CloudFront, through lots of various CDN technologies. But what about all of this dynamic content that gets created and needs to be analyzed? This is a picture courtesy of Crown Castle, and I'm not sure if you guys know who Crown Castle is. They're not normally shown in context of data centers, but this is a map of Crown Castle's infrastructure, and they own 40,000 towers in the United States, shared infrastructure towers where your cell phone signal comes from. Imagine what a data center would look like if we could put data centers embedded close to the user, last mile, right, as close to the edge as it can be, literally cross-connected from the radio access network, which is how we get our cell phone signals, and then cross-connected into the cloud. This is a map of where we are right now in Milpitas. Now check that out. This is how you solve for 163 zettabytes of data on the planet by 2025. You put meaningful density, 150 kilowatts potentially, out at the edge, tower by tower, as close to the user and as close to where that data is being generated as you can. This allows you to do a couple of things at the edge. Number one, all of the data that's being created, we're friends with an observatory that does this massive array of telescopes. And when the array is open, it's collecting 7 petabytes of data a second of the universe. How do they get that in to do data processing? How do you do any sort of machine learning? And today, this particular observatory ships hard drives around. And I kid you not, I read an article just last week about exactly a service offered by a very large cloud service provider that literally ships your hard drives around. And we think there's got to be a better way. The one thing that cloud has shown us, and the one thing that just the evolution of IT and the maturity that we're going through in terms of how we manage that IT has shown us, is that humans don't scale well with automation. We just don't scale well with the type of complexity and the type of growth that we're seeing in cloud computing today. So let's take a look at a typical, what we call backhaul. And you can just think of backhaul as data transport, because that's what it is. So today we're driven by the Internet of Things and the industrial Internet of Things. And we've got our cloud providers, and everybody's trading in their CapEx for OpEx, and we're putting more stuff in these big centralized cloud locations. When we're augmenting these big CSP data with regional data centers, of course, you've got your big regional data center carriers that are able to accommodate those. But in every case, off of the devices, which are largely connected to an LTE network, in the future a 5G network, potentially in the future unlicensed spectrum like 60 gigahertz or CBRS 3.5 gigahertz unlicensed spectrum, we've got this latency dilemma that we have to solve for. So off of the telephone, which I don't have in my pocket but I keep pointing to, you have a round-trip latency back through the tower, the exchange, a central office, a carrier hotel, cross-connected, IP termination exists. It goes out to get its resource, and then it travels that same path all the way back. And companies have solved some of this by creating things like NVGRE tunnels, or doing L2TPv3, or doing MPLS circuits, and you can cut a lot of that out by doing some of that. But in general, this is sort of the path we take to get to the cloud. And then you've got your regional data centers, and you've got your average 50 millisecond round trip or one trip decision making capabilities, which is pretty good for a lot of things. You can actually cut out a lot of latency. I mean, you can cut it by about 50% in a regional data center. But what about low latency augmented reality? where you need a sub 10 millisecond connection before your inner ear gets you nauseous when you look around and you see the screen trace you, follow you, shadow you as you're looking around. Or that low latency autonomous driving capability. An average car going 60 miles an hour covers a third of a football field every single second. An airplane goes even faster. And in the world of 2020, where we've got magical drones delivering all sorts of things to us, how do we solve for the airliner that has deviated off of a flight path when it's coming in for a landing in Chicago O'Hare, and there's a drone that's in the way? How does that drone make a very low latency decision about getting out of the way of this airliner? We think the world needs sub 10 millisecond round trip decisions for tons of new capabilities, tons of new use cases, user termination, life sciences, autonomous driving, AR, VR, industrial IoT. These are the use cases that we think about. So it's funny, this morning somebody said, oh, I like that you use Hunter S. Thompson, he's crazy town. We're kind of crazy, I guess. We've taken a very contrarian view to the edge. And as we went down this rabbit hole, we discovered some really interesting challenges about what happens at the far edge of the network. At the far edge of the network, how do you solve for not 4 data centers, but 40,000 data centers, all decentralized? Challenge number 1, a standardized truck roll. So public enemy number 1 for any enterprise thinking about procuring anything is vendor lock-in. How does Vapor, how do our customers, how do we as a customer, how do we think about how to allow vendors to differentiate where differentiation matters, but standardize on interface and interface connections that matter to us but may not be a differentiator for that OEM or that ODM? How do we allow innovation to continue? How do we allow it to prosper? And how do we go to market with people that still allow us to deliver a standardized truck roll where at 40,000 different locations, I can guarantee my customer that no matter if it's Flex or Groupware or Dell or HPE or any other vendor, how can I ensure that I can manage that box, I can sense that box, I can understand the performance of that box, and we can offer the SLAs and we can offer the operational agreements that customers expect. Solving for this standardized truck roll was a paramount requirement for us to be able to succeed. Differentiation for differentiation's sake is a terrible thing, and it's even harder to support in production. So that was challenge number 1. Challenge number 2 is this lights out operation. When you're 40 miles from the nearest person who would have to get in their car and drive to an edge location to service a box, or worse yet, a power shelf or some part of the M&E plant, the mechanical and engineering plant for the data center, fails. How do you understand that as a NOC person? As somebody who is delivering an SLA to their customer, how do you solve for that sort of telemetry? Vapor has developed an open source, completely open source GPL license, same as the Linux operating system. I'm sure everybody in this room probably uses inside of their data centers. We have built this open source solution called Open Data Center Runtime and Environment, to which we are contributing to Open 19. So this will be one of the contributions that we're making to Open 19. We've got lots of neat innovations that we're working on that we will be contributing. But this is a big deal because even ourselves, while this could be something we could take to market and we could differentiate on, we could say these APIs, they're ours, the real estate is what matters here, and we're going to win by locking you into a service that we control, that didn't feel right to us. We wanted people to manage their infrastructure at the edge, the far edge, no different than they could manage their infrastructure in their core data center. And that resonated with a few folks, and very early on in Vapor.io's existence, we decided to open source all of OpenDCRE, which you'll see as a contribution. And then the last thing, and I think this is probably the most paramount. Today, in these pristine data centers, we're building 5 nines of redundancy. How many people have you heard this? I need 5 nines. That's a huge thing in data center land. And we did this in computers once. We called them mainframes. And we built lots of fault tolerance vertically into something, and we ensured that your 480 volt 3-phase had substation 1 powering your A channel, and substation 2 powered your B channel. And you had lots of UPS systems, and you had lots of, this was the way we built data centers for decades. But what we're finding, and in this world, our applications expect 5 nines. In fact, our applications expect 100%. Our applications aren't aware of a fan wall failing. Our applications aren't aware of an HVAC system or a building management system going out. Our applications are designed to be as dumb as they can. There is the rack, and that is no man's land for the data center. You've got your critical environment guys below you working on facility stuff, and you've got the IT folks that are racking and stacking, and the application developers that sit on top of the rack. And that poor rack is sitting there just waiting to tell somebody to go fix something that may be dependent on the building and the critical environments, or it may be dependent on some other component in the rack itself, a bad memory module, a bad hard drive, a bad sensor or something. So what if our applications were autonomous? What if our applications could literally sense and understand the physical world that they lived in? So now, out at the edge, where you are 40 miles away from the nearest person, the application can fix itself. And this allows us to scale the edge as we go out and deploy 40,000 locations of data centers, which, by the way, is 6 gigawatts of data center capacity. So because Open19 uses a standard EIA rack, we were able to retrofit very, very quickly. What you're looking at here is the vapor chamber, and all this is an optimized rack infrastructure for density and footprint, rack density and footprint optimization via lots of physics-related technologies, Bernoulli principle, Venturi effect. Maybe just really quickly, by show of hands, who here knows where the 19-inch rack came from? Like where it originated? So a lot of people don't actually know this. It came out of the 18th century railroad switching era. That's right. Our data centers are powered by rack infrastructure that came out of the railroad industry, adopted by telco, adopted by music industry, and then adopted by IT. Compaq was the first company to own a patent around the rack for the data center. So here we are taking a cold air particle and moving that cold air particle horizontally. And as you know, there's a direct relationship between energy and heat. So as we add more density in the rack, we have to create more air volume in the hot aisle, we create more space in the hot aisle, and we have diminishing returns on how dense we can actually get. And we have to recertify hot and cold aisles. The ASHRAE comes in, or the NFPA comes in, and they do their certifications. The chamber was optimized specifically to help with the airflow. And because it's 19-inch, it's the only rack solution we know of. This may be a false statement. I hope it isn't. But as far as we know, it's the only rack solution on the planet that supports EIA, OCP, V1, V2, and now Open19. Because of the EIA capability, it's huge for us to be able to support, again, the type of gear that goes into these edge data centers. This is the way that we wanted to solve for that edge truck roll. On the sensing side, we've been working very closely with future facilities and understanding how the chamber is operating at the edge is absolutely paramount to our ability to deliver these edge services. And again, Open19, the ability to take one vendor's box, another vendor's box, plug them into the exact same rack over the exact same backplane, standardized network, standardized power, standardized interface for how you manage that from an out-of-band capability. We're adapting our software, we're adapting OpenDCRE, and we're, again, contributing that to the foundation. And I'd just like to show you guys what this sort of looks like out at the edge. Future Facilities worked really hard with us. But imagine, Flex has a booth back there with an HTC Vive. Imagine being able to put on a pair of VR goggles and walk around one of 40,000 data centers where you've got OpenDCRE data running live on, you hear this, check for the blinking lights, where you can literally put on a VR headset and you could walk around one of 40,000 locations virtually and see everything there is to see about your data center. With that, I want to invite anybody who's actually thinking about low latency applications, decentralized machine learning, low latency artificial intelligence, industrial IoT to come talk to us and help us build out the edge. Thank you very much.